Now that we've talked about the overall concepts of splitting, combining, and applying, let's talk about the order of processing in the apply phase. So we're going to kind of zoom in on how things are ordered when processing is done in the apply phase. Now this is very interesting. The Java Streams framework is designed to allow for variability in the order of the processing. We don't really care, you as a programmer don't really care the order in which the various tasks or chunks are run after they've been split up into subchunks. But you might care about the order in which the results come back. Or not. Sometimes you care, sometimes you don't care. So in general, you have little or no control over the order in which the common fork join pool threads run the tasks, but you can control the order in which the results come back, which may seem a little odd, but it turns out to be useful. So just to reiterate, the order in which chunks in a parallel stream are processed is intentionally non-deterministic, which means that you can't predict ahead of time how it's going to behave because it depends on a bunch of factors that you have little or no control over. Now, the underlying Java execution engine, like the common fork join pool, has a little bit of knowledge of this stuff, but even it really is at the mercy often of the underlying operating system and thread scheduler and hardware and so on as to how things actually run. And again, that's by design. It's good. It makes it possible to optimize things at different levels. And even for the same input, you could end up with different behavior between successive runs of your program, just because of the way that parallelism is designed to work, at the hardware level especially, but also the operating system level too. So you don't know, you don't really care the order in which these things run. So because you have little or no control over it, you shouldn't sweat about the fact that you don't have a way to have an influence over this. Why this is useful, why is non-determinism a thing? It allows optimizations by multiple layers in the overall hardware and software stack. So the scheduling and the execution of tasks can be done in all kinds of clever ways by the fork join pool. We'll talk about that later. I'll reiterate it or give you a preview in a second. The virtual machine gives it opportunities for optimization. Of course, the hardware, the cores, they can do all kinds of speculative computing and out-of-order execution and all this good stuff. And the common fork join pool uses this cool technique called work stealing in order to decide to run things in different orders based on which jobs finished earlier. So that, again, really demonstrates the inherent non-determinism of this whole thing. The fork join pool ahead of time doesn't know how long each job is going to take to run, each of the tasks it works on is going to run. So it doesn't make any guarantees about the order in which they run because it's going to try to maximize overall throughput, not keep track of the order in which things run and always run it in the same way. So we'll talk more about work stealing a little bit later, but in a nutshell, if a thread in the common fork join pool discovers that it's out of work to do, out of tasks to process, it looks around in the work queues of other threads in the common fork join pool and steals their work that they have not yet begun to process. So that's a quick overview of the order of processing. And now we're going to take a more leisurely tour through a bunch of examples that are going to demonstrate the effects of these the order of processing features in Java parallel streams.